In this video, we are going to be expanding logarithms. So at first we have our rules above, and on this side is the condensed version. So if it's condensed to be multiplication, when you expand it, it's going to be addition. So multiplication on the inside of a log means addition when you expand it. So you have your condensed versus your expanded form. These are the same rules as exponents. So when you multiply bases, you add powers. When you multiply on the inside of a log, you add on the outside when it's expanded. When you divide bases for exponents, that meant subtract the powers. So here, dividing on the inside of a log means subtracting on the outside when you expand it. And if it's raised to a power on the inside of a condensed log, then that's going to be multiplication on the outside, just like a power to a power meant multiplication for our exponents. So we're going to apply these same rules to expanding these logs. So at first I can start them with two steps. So looking at this first example, we have ln of x to the fifth divided by y to the third. And we want to expand it fully. So of these three things, the first thing I notice is we have some division. Division on the inside means subtraction when we expand it. So that's what we're going to do first. We're going to say this is really ln of x to the fifth minus ln of y to the third. Anything in the denominator is going to be subtracted. Now looking at what I have left over, I have an x to the fifth. To see if it's fully expanded, I want to check that there's these three things. So is there any multiplication inside? There's not. So that's good. Is there any division left on the inside there? There's not. That's good. But there is a power. So I'm going to bring that power out front as multiplication to fully expand it. So you check what's left on the inside to see if it's expanded or not. So we need to pull out 5 times ln of x. That last property says if you have a power, multiply it out front. Same thing with my next log term. We have a y cubed on the inside. There shouldn't be any multiplication, division, or powers left. And there is still a power, so we're going to bring the power out front as being multiplied. So we have minus 3 ln of y. Now when you look inside each log, you just have an x in the first one and a y in the second one. So there's no multiplication, division, or powers. If we look at the next problem, we have log of 1,000 times x times y to the fifth. So we're going to take all of that multiplication on the inside and expand it to be addition to start. So I'm going to write it as log of 1,000 was multiplied on the inside. So when we expand it, it's log of x getting added. Again, it was times y to the fifth on the inside. So we're going to add log. These are all logs of y to the fifth for the last one. Now we have log of a number, so I'm going to grab my calculator and just plug in that number. If it turns out to be a decimal, I'm going to leave it as log of 1,000. If it comes out to be a whole number, I'm going to write it as a whole number. So log of 1,000 comes out to just be 3, because 1,000 is 10 to the third, so log base 10 of 10 to the third is just 3. Next piece, we have log of x. So I want to see, is there anything multiplied, divided, or raised to a power? There's not, so that one is good to go. We're just going to write it as plus log of x. And last one, we have y to the fifth. So is there any multiplication, division, or a power? There is a power, so we're going to bring that power out as multiplication. So we have plus 5 log of y. So we're going to keep going with this. I might start doing it in one step because that usually ends up being a little bit easier actually. So anything multiplied is going to be added. Anything in the denominator is going to be subtracted. So as I expand this fully, we have log base 3 of 15. So I'm going to grab my calculator and type in log base 3 of 15. I'm going to use the math button and scroll down to letter A to change base. So we have log base 3 of 15, and it comes out to be a decimal, so we're going to leave it as just log base 3 of 15. That is multiplied times x squared in the top. So if x squared is in the top, it must be added when we expand it. I'm going to have to bring that power down, so I'm going to leave some space. That log of x had to be added because it was multiplied in the top. And then your power 2 gets multiplied up front. Next term is a y. It's in the denominator, so we're going to subtract it. I'm going to leave some space for the power. We're going to have subtracting log of y. And it was a square root in there. So square root, we want to remember what power that really is. That is y to the 1/2. The third root is 1/3. Fourth root is 1/4. The square root is just 1/2. So we have minus 1/2 log base 3 of y. And now our last term is a z. So that z is in the denominator, so it's going to be subtracted. If it was in the top, it would be added, but we're going to do subtracting log base 3 of z. And then we want the power on z out front. So we have a 3 log base 3 of z, because it was raised to the third power. And there's our final answer in one step. We pull out all the powers as multiplication. If it's in the numerator, it's added. If it's in the denominator, it's subtracted. Let's keep working with that. This next one is an ln problem. So we're going to separate and see however many ln's we have. So first we have ln and we have x on the inside. Since it's in the top, it should be a positive. It's not going to be subtracted unless it's in the denominator. So we're going to put ln of x. And then we want the power multiplied out front. So remember, the square root is a 1/2 power. So we're going to do 1/2 ln of x to start. In the bottom, we have a 4. So are we going to add or subtract that ln of 4? We're going to subtract it because it's in the denominator. Anything divided in the denominator is subtracted. I'm going to grab my calculator and plug that in, and if it gives me a whole number, I'm going to write it as a whole number. If it gives me a decimal, I'll leave it as that exact answer, ln of 4. And it's a decimal, so I'm going to leave it. We have ln of 4. And then my last piece, I have an e. It's in the denominator, so I'm going to end up subtracting it. I have ln of e, and it was raised to the power 2, so that power is going to go out front as 2 ln of e. And then I have ln of e, so I need to check it in my calculator. And this actually gives me a nice whole number. Log base e of e, or ln of e, is just 1. So we have 1/2 ln of x minus ln of 4, and then we have minus 2 times 1 is just going to be a minus 2. Log base e is ln, so ln of e is 1. Just like log base 5 of 5 is 1. Log base 64 of 64 is 1. And now for our last one, we have a lot going on here. We're going to separate out this log base 3 into a bunch of pieces. First thing I have is log base 3 of 27. My first thing in the top, it was in the top, so it's going to be a positive. Log base 3 of 27. We'd subtract if it was in the denominator. I'm going to grab my calculator and see if that comes out to be a nice number. So I'm going to do math and scroll down to log base and change it to log base 3 of 27. Well, 27 is 3 to the third, so log base 3 of 27 ends up being 3. So that part simplifies out nicely. The next thing I have is it's multiplied by the 4th root of a. So since it's in the top, we're going to add log base 3 of a. I'm going to leave myself some space for that power out front. So when we expand the power, it gets multiplied out front. So we have a under a 4th root, which is really a to the 1/4. So we have 1/4 log base 3 of a. Next one we have b, so I'm going to add it since it's in the top. Log base 3 of b. And then I'm going to pull that power out front, so it's going to be plus 16 times log base 3 of b. And lastly, we have a c in the denominator. Since it's in the denominator, it's going to get subtracted. We have log base 3 of c. And there's my final answer. Everything's expanded. I can double check. Inside the log, there's no multiplication inside these logs. There's no division, and there's no power inside. So you know it's fully expanded if it doesn't have any multiplication, division, or power left on the inside.